What? Go ahead. Alright, so let's just get started. 7-1, Pythagorean theorem. I know that we've used the Pythagorean theorem a bunch during first semester, but we never technically officially defined it. Well, you officially define it today. Yay! Now, when you're working with the Pythagorean theorem, there is this only works for what type of triangles? It only works for right triangles. Guys, inside right triangles, you have three sides, hence the word triangle. Convenient. Now, there is one side length that is there always that you can define. It's called the hypotenuse. Which side length in a triangle, of a right triangle, is the hypotenuse? The one across from the right angle. It's the longest side. Okay. The hypotenuse is always the one across from the right angle. Hypotenuse. This is always your C value. The hypotenuse is always the longest side length because it's always across from the right angle. If you have one right angle in a triangle, you can't have another angle bigger than that. Because you'd have too many degrees, then you wouldn't be able to make a triangle. That's why that works. Did I ever show you guys that you can do that? Have more than one right angle? I did? I never showed you that? You can. We just don't show you. You know what this is? It's a sphere. Okay. I did tell you this. So when you have a sphere, if you go along the, what's it called, like the equator, and then you come up, they make right angles, so you can actually have three of them.
I can't catch it.
These other two parts are called legs. They're interchangeable with A's and B's. Okay? It's not a big deal. Now, guys, what's going to happen a lot of times now, it's not just solve for the hypotenuse like we did first semester. We're going to solve for missing side legs. Okay? You're going to use two-step algebra. I know. So exciting. So you'll do stuff like this. Skip around. We're going to start solving for x. And this is where it's important that you guys have the calculator. Because sometimes you'll get nice, clean numbers, and sometimes you'll get ugly root numbers. So what I want you guys to get in the habit of when you're dealing with second semester stuff, I really want you guys to be able to draw pictures. The more visual representation you get, the easier everything becomes. In a couple of weeks when we start working on trigonometry is nothing more than perspective. It's all about where you are located in a triangle and what you are looking at. So the better you get at drawing stuff out, the easier it'll be. Yes, ma'am? What's that? You're going to use it all the time, yeah. Do you have yours? Do you have your calculator? I know, so that's why I'm sitting there looking at it going, tisk. Yeah, one of you guys should probably go grab one. Whoever's closer, go grab it real quick. You really need to have it. That way you can get to see how some of the tricks will work. So as you write this out, again, it's nothing more than filling in the blanks. There will be there will be a couple of different ways that you can write this out. Okay? There's going to be a couple of easy ways to write these things through and solve them through. Sometimes people square it right away, then rewrite it. What I mean by that is they'll write x squared plus 81 is 225. And they'll just write that down. Knowing that you have to solve for x, sometimes they'll just move that 9 squared over to the other side right away. Okay. Two-step algebra problems. X squared is 144. How do you undo square root? Yes, sir. Square root, very good. Now, what happens when you take a square root over an equal sign? You remember this from last year? Whenever you take a square root over an equal sign, your answer, you do something to your answer.
Is it canceled out?
What's that?
Canceled out.
The exponent will cancel out, yes, because the square root of junk squared is just junk, so that's where we get the x. But what happens with the other side? All right, what does square rooting a number mean? No. Let me ask you this then. What is the square root of 144? 12, okay. So that's telling me that two numbers that are the same number, when multiplied together, I get 144. 12 times 12. There's another number that does that as well. Very good. Right. So what happened is that whenever you take a square root over an equal sign, technically your answer is always plus minus. Okay? It's always going to be plus minus. Now you did this last year also when you worked with quadratics. If you had to solve quadratic equations and whatnot, you take a square root and you work it through. You might with two different values. It does the exact same thing here, but what you need to remember is that what does that value of x represent? In this case, it's a side length. Can I have a negative side length? No. So when I'm dealing with this scenario, just this value being 12, I cannot let that be negative 12. The reason why I'm reminding you of this rule about plus minus is because later on, you will see equations where you're going to get, let's say we'll have a circle. I know it works in here sometimes, where you get this portion might be x plus 3, and let's say you get x is equal to negative 1. Well, what's negative 1 plus 3? 2. So could I have a negative here? Would it be okay? Yeah. Now, that's what I'm trying to remind you, is that sometimes negatives are okay because it's dependent upon what you're substituting them into. If I substitute in and I get a positive side length, then I'm all right. And it does happen. All right. A lot of times you guys will forget about that little negative trick there. All right. Just want to remind you of that. Because I know you did that last year. So you get 12. Well, do the same thing on the other one. What do you get? 15. Very good. When you do the other one, you have 8 squared plus x squared is 17 squared. Does it matter where the 8 and the x go? Would it be either one? Doesn't matter. You do the same basic idea. Okay? You take the x squared, it's going to equal, right? I'll show you another shortcut way of doing it. I could do that. Instead of writing it all out, squaring it and writing it all out, knowing that I'm going to use my calculator to solve this, all I have to do then is use my calculator. Now, my calculator doesn't simplify radicals, but it does have the same keystrokes that you will use. For example, all I'm doing is this, 17 squared minus 8 squared, and I hit enter. And now, do you know how to take the square root of an answer in your calculator? If you don't, refresh it, because you're going to use the answer button a lot. The second root of your answer. Your answer button is the same place as mine is, it's at the negative symbol. Okay? And hit enter. And there's your answer, 15. 8 squared plus 15 squared is 17 squared. It's a triple. Remember we said something about those last semester too? Okay. Just a reminder on how to solve two-step equations here. And obviously you're just using the calculator. It should make you happy. Less work. Take a minute and solve those two, please. Now, a reminder, we'll talk about that. You could still get a square root in your answer from time to time, depending upon what the side length values are. So in this first example, you got to find the other length. You have a 10, something, and a 24. So when you use Pythagorean theorem on that one, I think you wind up with, well, you got x squared plus 10 squared is 24 squared. Is it 476, I think?
Yeah.
So you get 476. When you take the square root of that, it gives you a simplified radical. 2 root 119, I think?
Yeah.
So that means your side length is 2 root 119. Now, when I bring that together with the side length of 10 to get the area, it just looks like this. Half of 10 times 2 root 119. Well, what's half of 10? What's 5 times 2? So your answer is 10 root 119.
Feet squared.
Something squared. Remember, when you're dealing with radicals, and you're multiplying everything together, it's the same idea as if you had the square root of 3 times the square root of 5. Since those values both have the exact same, what we call nth root, they're just a square root, you multiply them together, you get the square root of 15. Now, guys, if there was a 2 here and a 4 here, what number would go here? 8, right. You multiply the numbers on the outside, and then you multiply the numbers underneath the radical together. That's all you do. Or you throw it together in your calculator like you did, and just put it all straight through. You type this into the calculator, you're going to get that as an answer. It does the work for you. The multi-view calculator is worth every single penny that you have. And if you have, hopefully you have more than 1,500 pennies. Oh, wait. Yeah. That's $15.
How would you feel if somebody gave you
With pennies, I think it'd be pretty funny. Because I think pennies come in rolls of 50 cents. So you need 30 rolls of pennies. And a roll of pennies is a little bit bigger than a thing of chapstick. Okay. All right, let's do the other one. Same idea, guys. Heads up, please. One more of these, and I think we might be a little ahead, which is fine. Give you some time to get started. You never done that before? Never snapped a porn?
Imagine.
Someone down the stairs up there.
It works better with, anybody have a nickel? You got a nickel? Here, man. I'll try not to. You guys have never seen people snap quarters or stuff before? See, here's the problem. This is what we call a generational gap. Back in my day, we actually had these things on walls called payphones. You may or may not have seen them before on TV shows and or movies. The payphone, this is an important story to learn. The payphone was there so you can call home and say, hey, come pick me up. And then we realized we'd call collect and say, I'm done, pick me up. And you'd hang up right away because the caller would say, I'm done, come pick me up to your parents. Well, you guys don't carry change, ever. I don't think change will be around. Pennies will be gone in your lifetime. But what we always had, since we always carried quarters on us, we were always at lunches and stuff, instead of playing on our cell phones, because we had to have conversations, we would fling quarters at each other by snapping them. How you do that, you can snap your finger, right?
My car broke. I can't go.
All you gotta do is you set this just barely on the inside of it, and you snap. And you snap. It does. If you hit somebody just right, it hurts.
What? How did you just throw that?
I didn't throw it. I did not throw it. I didn't throw it. All I'm doing is I barely put it in where I'm snapping. I lean back.
No, he's really snapping. No, he's not throwing it.
I'm not throwing anything. I'm snapping.
I'm gonna do that one. They say you can't throw.
Hey, who's got an iPhone? Do a slow-mo. And watch it in slow-mo. I stand right next to where I'm going to snap it and slow-mo video it and watch it. I'm just snapping. I'm not throwing anything. Kathy, watch out. I want to hit you in the head. Can you zoom to my thumb? You ready?
I don't know if it's gonna go that fast. Here you go.
That was a bad one.
Wait, should I go from like right here?
Just
I did, but it just goes so fast.
That's why it's so much.
That's why it's slow
Right, but
motion.
I can't follow it.
Don't follow it. Just watch my thumb. Keep zoom right there, okay? Ready?
You have to do it.
Wait, keep it at your thumb?
Yeah. Tell me when you're ready.
Oh, I've been right. Okay, go.
Bad one. We need to snap off.
You're gonna hear her voice in slow motion going.
Whoa. So yeah, this is what we did. We just sat there and
I hope you hit someone, then you won't get fired.
nickels are great. Nickels work really, really well because they're just heavy enough. A quarter, if you do it too many times with
I
quarters.
like slid down your sleeve right here.
Wait, did I write
Yeah, just snap it. I'm not throwing it. See, even my hand moved backwards. It recoils.
it? does though. I'm just gonna go on the street.
I will say, if you want to learn, use a penny because they're lighter and they won't hurt your knuckles
People on the street.
to start with. It right on the edge. I put it down. That's when my elbow goes up. And I need one. Yes, ma'am.
I was thinking that.
Yeah, that's all it is. And when we do that to each other, you get bumps. You go. No, I wasn't. I'm surprised you guys have never seen that before.
No one ever.
I will say this: when if you do start to practice doing that, be careful on how you snap. A lot of times, if you start snapping it, I see so many people learning how to do it. If they don't have it placed right, they'll come back and hit you in the head. And I'm not kidding; it happens because if you place it off to the side a little bit, it'll pop out the wrong way. Okay. So here's what I have you guys doing tonight. I put it on the calendar for you. If you go to the this is up and running again, so this should be okay. If you go to the calendar, remember on the website itself.
Change the color. I don't like that.
If you click the January17, it comes up with a thing that says more details. You guys all remember that, right?
Yeah.
Okay. Anytime we have worksheets and whatnot, I'm going to try to remind myself to always attach it as a PDF file. It's a little bit easier for you guys to open up then. There it is. Okay. This is the worksheet I have you guys working on tonight. Once it loads, I emailed this to you as well because the Google wasn't working very well. I think the hamster fell off the wheel. But the questions I had you guys working on this one are those, 2 through 12. Okay? So it's 2 through 12 on the front side and then 26 through 38 on the other side. Shouldn't be that difficult. See how you guys do. We're going to be in this section for a few days. We'll bring in some more triple stuff and working backwards from Pythagorean theorem between tomorrow and Thursday. We will start special right triangles on Friday. It's hugely super important. Please make sure you have that multi-view calculator by Friday. Yes, sir. I was just something I had on there. Don't worry about it. Okay? Oh. Don't you know to break the line of the orange first before you try to peel it and cut it apart? Breaking the rind is that difficult?
And then we would go over it.
I probably should have.
They're changing it.